Hey, welcome ladies and gentlemen. Hopefully this video works and we are good to go for tomorrow. That is the hope. Okay, so today we are calculating exponential growth. So essentially we're applying this. This is where exponential functions are the most applicable in determining growth and how things are going to change. So this is the model we're going to be using. This whole thing essentially is what we are using. So you already saw A is the start value or the y-intercept. Okay, if it helps you, make sure you realize that that's where it starts as well, when x equals 0. Okay, so that's the start when x equals 0 or at the beginning of time. Okay, in this model, yesterday we said in our class that this whole thing was B. Okay, so that was the growth factor. Right now we're talking about the growth rate. Okay, so this is the rate of growth, usually given as a percent. Okay, so usually it's a percent. That's going to be important. And finally, T, whoa, let's undo that. T is time. Okay, how long are we doing this whole thing? And really today is just all about word problems and seeing how to apply this. So we're going to look through this. You deposit $150 into a savings account that earns 5% interest, compounded yearly. Okay, find the balance in the account after 10 years. All right, so really important to recognize our start value is right there. That 150 is the start value. Okay, the account earns 5%. Okay, well, we have to get a number for that. Okay, 5% translates into 0.05 as a percent. Remember, you can figure that out because you can do 5 divided by 100. Percent is per 100. Okay, so that's 0.05. Okay, you can also just move the decimal over 2 times. Okay, and the 10. Okay, well, T is after 10 years. Okay, how long will this last after 10 years? Well, we can grab our calculator. We can put this into our calculator. So we're going to write out the equation. 150 times 1 plus 0.05 to the 10th. Okay, so again, this is where having that calculator, super critical, and knowing how to type it into your calculator is also important. Okay, so 150 parentheses 1 plus 0.05, okay, all raised to the 10th. Remember, that's like raised to the 10th is like the caret button. Okay, and if you put this into your calculator, you should get 244.3344. Okay, so it's like 0.3341. We're talking about money here. So recognizing a bank is not going to ever round up. So we say we truncate. Okay, so on the calculator, it's like 0.3341. But if it's money, it's only talking about those 2 decimal places. So truncating means we just cross it off. That is our final answer. So this is all gone. We just get rid of everything after those first 2 decimals. Okay, so all it is filling in, recognizing, working through these. Okay, the owner of a 1953 Hudson Hornet. Oh, that reminds me of the Cars movie. Oh, convertible, sold the car at an auction. The owner bought it in 1984 when its value was $11,000. The value increased at a rate of 6.9% per year. The auction took place in 2004, what was the approximate value of the car at the time of the auction? Round your answer to the nearest dollar. Okay, so what we have to figure out there, okay, in 1984, when its value was 11,000, so that's the original time, that would be our start value, 11,000. Okay, the value of the increased, well, the value of the car increased at a rate of 6.9% per year. All right, so again, remember, 6.9% equates to, divide that by 100 and 0.069. So that's the rate, 0.069. Okay, now for time, we have to figure out, we have to do a calculation here. So look, they bought it in 1984 and the auction took place in 2004. How many years was that? Well, 2004 minus 1984. I mean, hopefully you can see that that would be 20 years. So that's our time. Okay, so plugging this in to our equation, our start value. Okay, so the value of this is equal to the start value, 11,000 times 1 plus 0.069 to the 20th power. Again, it's important that you can put this into your calculator. We're not putting in the y equals. That's essentially just so that we know we are calculating a value, okay? So 11,000 times 1 plus 0.069 all to the 20th. Whoa. All right, so again, on my calculator, I see 41777, comma, or point, not a comma, point 91763. We're talking about money though, again. So I'm going to truncate. I'm not going to round up. You know, I mean, essentially the value is worth 0.92 or 92 cents, but no, I mean, nobody's going to round up there. So for money, I'm just going to cut right off. Okay, I'd like to round up. You know, if it's something that I owed the bank, I'm sure they'd round it up, but not in these scenarios. Okay? Finally, a recent college graduate accepts a job at a law firm that has a yearly salary of $39,000. The law firm guarantees an annual pay increase of 3%. What will the salary be after 6 years of work? Okay, so I want you to take a minute, pause the video, try to work this one out all on your own, and we'll come back and check how you did. All right, so hopefully you see that there's your start, 39,000. Oops. All right, and the law firm guarantees an annual increase of 3%. Okay, so again, 3% equals 0.03. Okay, so that's what I'm putting right here, 0.03. Okay, how much will you make after 6 years? Okay, so at a time of t of 6. All right, plug these right in. All right, so 39,000 times 1 plus 0.03 to the 6th, okay? 3%. Sounds like a lot. I don't think it's going to equate to that much more, but let's find out. I'd like to get 3%. To the 6th power. Whoa, well, that's substantial. So in 6 years, you are making 46,568.03. So again, the law firm's not going to round up. So there's what your salary will be. So after 6 years working there, look at, you've gone up $7,000. Way to go, you. Okay, hey, down here, you've got some room. I want you to write any questions you have, just a little sentence. I get this, or I'm confused by. Okay, just one little sentence. I'll check it tomorrow. Have a super evening. Bye.